I'm Mark Riley, the head of the Department of Biological Systems Engineering. We are the home for the undergraduate program in Biological Systems Engineering. This is a very diverse major that integrates engineering activities applied to living systems. And the typical application areas run a very broad area, from health applications to biologically based fuels and products, food, and water. I'd like to tell you a little bit about our academic program over the next few minutes. So the BSE department and program are housed in Chase Hall, which is on East Campus, at the end of the lawn on the western side of East Campus. Myself, I'm a professor and the department head in Biological Systems Engineering. I grew up in southeastern Michigan, went to school at University of Michigan and Rutgers, and I was on the faculty at the University of Arizona for about 15 years. I came to UNL in 2012. And the reason I came here was because of the strength of this department and these programs. So we have tremendous faculty and students, and the kinds of activities that they both do are absolutely tremendous. So over the next few minutes, I'd like to tell you about some of these incredible activities. So myself, my research and my teaching has focused in bioprocess engineering. My work is to develop sensors that really span the environmental applications to biomedical applications. In one example, we have been detecting viruses in drinking water by using a cell culture system that can look at whether viruses are actually infective or not. So biological systems engineering is the application of math, science, and engineering principles to living systems. So this is one of the newer disciplines within engineering, and it has evolved for many reasons, but a large part of that is the development of sciences in addressing living systems. So there are tremendous opportunities to take foundational developments in the life sciences and make new products, new devices, and new solutions. Biological systems engineering takes advantage of those advances. So why would one want to be a biological systems engineer? Well, for one thing, BSEs get to work with some of the neatest tools. They can work in areas from tissue engineering, developing artificial organs, to medical diagnostics, including ultrasound and magnetic resonance imaging. They can develop products from renewable energy to bio-based materials, or they can look at environmental solutions to some very complex problems. So what's happening today in biological systems engineering? Here's just a couple of examples of some advances in this field. So biological systems engineers are developing tissue engineered approaches, often using three-dimensional systems to generate organs and organ systems that can either replace the function of damaged tissue, or they can be used as a way to test new pharmaceuticals or develop new diagnostics. These are often developed into what's called an organ on a chip. You may have heard of the concept of a laboratory on a chip. It's a similar concept. There's a burgeoning area of what's called synthetic biology, which is utilization of genetics, but with a true engineering perspective, using design tools and looking at systems approaches of changing multiple genes at once instead of just one at a time. So here's an example of E. coli bacteria that have been modified to be able to produce and secrete what are called bioplastics. These bioplastics are biologically based materials that have the same similar functional properties as to many petroleum-based plastics. This has a tremendous opportunity to revolutionize how we generate products. However, there are tremendous engineering challenges that still remain. Another example is the utilization of information systems to evaluate the impact of the environment on people. So here's a publication that was recently made available in pulling together these pieces. So high-resolution topographic maps are used as an indicator along with sociological analyses to see where people live, to where they work, to where they recreate, to evaluate the risk of the spread of malaria. So this approach uses remote sensing. It uses an understanding of the local environment, an understanding of people, to be able to make predictions of how we should better allocate resources to be prepared for the spread of disease. So to reflect these diverse areas, the biological systems engineering major is also very diverse, and we have 3 separate degree options. So those options include biomedical engineering, environmental and water resources engineering, and food and bioproducts engineering. There's much overlap in the foundational courses that our students take in these areas, but then they specify what approach they want to head towards and take classes in each of those. So all of our students take a similar core set of courses, and these include biology, chemistry, physics, and math. They take a good cohort of engineering foundations, including statics, dynamics, and thermodynamics. And then they get into some of the discipline-specific courses, including engineering properties of biological materials, a biological thermodynamics course, instrumentation and controls. Throughout the program, it's very important that our students gain experience both in the classroom and beyond. So a large number of our courses have a laboratory component where students learn how to apply what they've learned in the course into some practical systems. For more information on our academic resources, please follow the link below. So now I'd like to talk a little bit about each of those focus areas. So in biomedical engineering, our students typically focus on medical imaging, tissue engineering, or rehabilitation engineering. We have a tremendous track record of placing students into medical schools and into professional schools. And in general, in this area, our students follow a one-third, one-third, one-third path. So one-third end up into medical or pre-health professions, one-third go to graduate programs, and one-third go directly into industrial positions. We have faculty research primarily in these areas, looking at ultrasounds for medical diagnostics, developing magnetic resonance imaging for tissue engineering, and developing gene delivery mechanisms that utilize new kinds of biomaterials to be able to more effectively replace damaged tissue. The environmental and water resources engineering area has a large focus on drinking water and on wetlands. So our students can take many courses in these areas, and water is one of the key strengths of academic programs on the campus at the University of Nebraska. And there are tremendous job opportunities in this area. So in many cases, our students end up working for environmental consulting firms, which are housed in Nebraska and in neighboring states. The bioenergy and food engineering area connects a large component of Nebraska's economic productivity. And this includes taking agriculturally produced materials and generating higher value products. In some cases, those products could be bio-based ethanol, could be biodiesel, and could be other advanced fuels. So one of the large drivers economically in these industries is utilizing all of the feedstock material to generate valuable products. So a great example for ethanol is what's typically called a byproduct, is the dried distiller's grains. These grains have tremendous value either as feed for animals or as sources for other kinds of higher value products. So our students gain experiences very closely tied to these industries. So I'd like to talk briefly about some of the really neat things that some of our faculty are doing. So Dr. Angela Pannier, who does a lot of advising for biomedical engineering students, has a laboratory focused on tissue engineering, gene delivery, and biomaterials. So the typical approach to deliver genes into a cell often will involve a virus. Dr. Pannier's research avoids that complication and uses alternative methods to be able to transform cells, to be able to introduce proteins and different functionalities into those cells. She uses this approach with some very creative kinds of biomaterials that help to guide the growth of cells into fairly complex organs and organ systems. And this leads to the tissue engineering approaches to develop replacements of organs and also to study embryology, that is the development of an embryo. So Dr. Pannier has a very large group, and she has many undergraduate students working in her laboratory. Dr. J.M. Sabaya is a distinguished professor of food engineering in our program, and he applies a very diverse array of engineering approaches to characterize food, from using what's called hyperspectral imaging, which is imaging using different wavelengths of light. He also looks at ways to apply some very complex models to improve cooking and packaging of different food materials. He has many interactions with a lot of companies in the region and is very helpful in being able to connect students to companies. So after graduation, our students have tremendous opportunities in where they can go. In the biomedical engineering directions, I've already mentioned the places they typically go. Environmental and water resources often involve a number of consulting companies working for U.S. Geological Services and the U.S. Army Corps of Engineers. They often hire quite a number of our students. There are quite a lot of jobs locally in Nebraska and regionally in the bioenergy and food area, including some large companies like Cargill, ADM, and Conagra, but also in some of the pharmaceutical and biotechnology companies like Novartis and Pfizer. So we have tremendous students in this program. And our students have won a large number of awards for a variety of activities. Two of our graduate students were recognized at the Spring Research Fair. Abby Kelly had one of the top 2 posters out of 60 submitted in engineering this year. Tim Martin received the UNL College of Engineering Outstanding Graduate Research Assistant Award. We have quite a number of student athletes in our department. Our students are recognized through Mortarboard and also through the College of Agriculture as in recognition of service activities. So our faculty are also heavily recognized for their outstanding achievements. Dr. Swidermach received the College of Engineering Faculty Research and Creativity Award. Dr. Dennis Schulte was honored for 36 years of service to the University of Nebraska. Dr. Schulte has played a seminal role in developing our academics, and a large part of why our program is so very student-centered is due to Dr. Schulte's activities. Evan Curtis, who I mentioned recently, was recognized from the College of Engineering as a Staff Award for Exemplary Service and Support, and Dr. Deepak Keshwani was recognized as a Superior Academic Advisor. Our department is very fortunate in having quite a number of scholarships for student support. So our department itself is operated through both the College of Engineering and the College of Agricultural Sciences and Natural Resources. And this provides more opportunities for our students to be able to get scholarship support. For more information, please see the link above. Our students are very active in a number of clubs, ranging from the Biomedical Engineering Society to the American Society of Agricultural and Biological Engineers, Society of Women Engineers. We strongly support our student participation in different club activities and different competitions. Here's a picture of last year's team for a competition called Fountain Wars, where they applied their knowledge in hydraulics and water resource systems to be able to perform a variety of tasks. This is very similar to a Rube Goldberg type of competition. A large number of our students in biological systems engineering also perform research, either through what are called REU programs, which are research experiences for undergraduates, or Nebraska's UCARE program, the Undergraduate Creative Activities and Research Experiences program. It's also very important for students to gain activities. Many of our students work on internships or co-ops, either working in the summer or taking some additional time to be able to gain experience with companies. So many of these activities are available. Staying connected with BSE is very easy to do. We have a large number of student club meetings and department activities. We also have a Facebook page and a LinkedIn group. Both of those have the name of Department of Biological Systems Engineering at UNL. And also our website has tremendous information for student activities, for career options, for information about academics, about scholarships, and background on the research of our faculty. So I encourage you to take a look. So in summary, the Biological Systems Engineering program has a diverse array of activities ranging from coursework to laboratory activities within those classes to student activities, from research to internships to club activities. We really do place a major emphasis in advising, and I think we do an outstanding job of helping our students to understand how they can best pursue their professional goals. So thank you for your time, and if you have any questions, do not hesitate to contact me or Mr. Evan Curtis. Thank you.